Hey guys, and welcome back to the channel. Part 2 of the MeTech 286 Atari clone. Now, as you saw in the previous videos, I did get the machine up and running. It was able to detect the memory, all 4 megabytes of it, but the system wasn't running very stable. So time to investigate. Because the goal of the video is to get a stable working system that we can then put back together and get a fully functioning MeTech 286 computer back up and running. But first, a word from our sponsor. And this video is sponsored by PCBWay, a full-feature custom PCB prototyping service. If you need PCB prototypes, SMD stencils, PCB assembly, flexible PCBs or advanced PCBs, PCBWay has got you covered. Shipping to more than 170 countries worldwide, processing thousands of PCB orders a day, PCBWay combines excellent pricing with excellent customer service. Check out their website to get a quote or get in touch with their friendly support staff if you have any more questions. Now, I pulled the original PSU from the case and I decided to test that. So, you know, the standard voltages, the 5 volts and the 12 volts were absolutely fine when hooked up with a small load. So that was already good. And also when hooking up this power supply to the actual main board, we saw that all the voltage rails, so not only the 5 volts, but also, as you can see here, the minus 5 volts, the minus 12 volts, and the 12 volt rails were all looking good. But the system wasn't running very stable because from time to time I got these beeps here and I didn't got anything on the screen. So yeah, it's always important to hook up a PC speaker to a motherboard like this when you're doing diagnostics. Otherwise, if you get a blank screen, you have no idea what the cause is. Now, the fact that this one beeps also doesn't tell you a whole lot of additional information because I had no idea what these beeps actually meant. So this is a Phoenix BIOS, so every BIOS vendor has its own specific beep codes, but I couldn't find any meaningful description for this beep pattern here. Now, what I did notice, among other things, is that this diagnostics card here that is typically used to diagnose issues with motherboards actually causes the motherboard not to start properly. So that was one of the reasons why we didn't see anything. Now, I also managed to free up the CPU from its socket here. So yeah, this little metal plate here was very tight, but after applying some pressure, I was able to remove it, and that exposes the Intel CPU, which is this nice little LCC package here, an Intel 8286 running at 12 megahertz, and it's the first time I actually seen one of these CPUs in the flesh. So yeah, really nice little package here. You don't come across these all that often. To put the CPU back in, you just need to align it to the socket. There's only one way of inserting the CPU, and then you just put this little metal bracket back in. It slides into the plastics on one end, and then you just slide it like so to push it in. Here we have the keyboard controller, which some people mentioned in the comments that also might affect the memory usage. Here we have the Western Digital Floppy controller and the floppy drive connector, which is embedded on the motherboard. The computer also has 2 serial ports provided by these UART chips here. We have Paradise onboard VGA and 256 kilobytes of video memory, as can be seen here. The power supply connector on this motherboard uses a different orientation than what we are used to, but it's a standard plug. Chips and Technologies provides the chipset, so there are 4 chips included on this motherboard here. So yeah, now that I finally managed to get the CPU out, I again removed all of the removable components and jumpers. I also removed this bracket from the motherboard, and then I decided to just give it a good cleaning using the dishwasher. And I figured this would do a more proper job of cleaning, and it would be a lot quicker. So I just used a very quick program here, a 30-minute program. I didn't use any soap. So yeah, just to give it a good cleaning here. And so yeah, after about 30 minutes, we were able to open her up, and you know, the motherboard was pretty clean, but that's always the case when it's still a little bit wet. So it's only when it completely dries up that you see if there is still some additional residue. I did clean it up with IPA afterwards, but the machine again wouldn't start after I assembled it again, and it took me a while, but what I came to find out is that one of these original RAM sticks here, these 1 megabyte sticks, was actually faulty, because sometimes it would boot, but it would kind of depend on how you inserted the SIP memory modules here, because there was one bad chip here, and if you put it in the first bank, then the computer would simply not start. So if I take this chip here, which is actually, according to me, a bad chip, and if I put it in the first slot, so I'm just going to be replacing these chips here, then you again get this kind of beep code from the motherboard. You get nothing on the screen and the computer doesn't boot. So I'm guessing that this stick is probably responsible for the instability. And of course, now that makes perfect sense, and it's a pretty, you know, straightforward conclusion to get to. But as you are working with this thing and you notice how, you know, in a bad state the motherboard originally was, and perhaps something went wrong during cleaning, or perhaps something was just fundamentally broken with the motherboard, it becomes very difficult to see, you know, the light at the end of the tunnel as you're dealing with a ton of issues. But there definitely was an issue with this memory chip. I had some similar issues as I was trying to get the floppy drive and the hard drive working on this machine, because I tried several of these IDE controllers that I had lying around, and it actually turned out that only this one here was working. The other two that I had were broken or not configured, because, you know, typically these things have lots of jumpers where you can enable, disable certain functionalities of the ports. Some of them are documented, others are not. For example, here I didn't have any documentation on this card. And it's always important when you're trying out this stuff that you actually, you know, take hardware that you know is working in another machine, and you're just not grabbing it from a bunch of hardware which is untested. You know, same goes for the floppy disk drives themselves. I have a bunch of them lying around, and I'm not really sure if they are working. Same goes with the floppy disks. I mean, sometimes these floppy disks work on one drive or they don't work on another, or perhaps they just end up breaking along the way. So you always need to make sure that you are, you know, hooking up peripherals that you know are at least working in another machine. Something that's easier said than done as you are, you know, trying to debug things. Even as something as simple as a floppy drive cable, for example, can cause issues. Another thing that we need to take into account is that this machine only supports a limited amount of hard drive configurations or settings. There is no auto detect, there is no user type, so what you end up with are these 47 drive types that you can select one from, with a predefined cylinder head and sector combination. And you just need to find like a hard drive which is capable of working with that. Now, the chances of you having a hard drive with the exact same specifications as one of these 47 are pretty slim. I have this entire box here of, you know, very old hard drives ranging from 20 megabytes all the way up to 300 megabytes, and I was convinced that at least one of them would be one of the predefined types as it was defined in the Phoenix CMOS setup utility, but I couldn't find any exact match, despite the fact that these are really old hard drives, and you know, they are more or less time period correct. I mean, this one is obviously coming from an Apple, but it is a 40 megabyte drive. Also, some of these old Connor hard drives are typically found in these older computers. Now, this is a 300 megabyte hard drive, so it's a bit too new, too recent for a 286. But this one here, which is also a Connor drive coming from an Olivetti machine, which I think is a 40 megabyte hard drive, in theory, this would be able to work. if it wasn't for the fact that there was a short here in the tantalum capacitor and the thing just blew up as I started it. Seagate is also a very popular brand, which was very popular back in the day, and lots of BIOSes have predefined settings for these Seagates. There was one SCSI drive in here. I think it's also a pretty old one. Obviously not able to hook this up to the 286. But yeah, I think this investigating all of these hard drives here probably merits a video of its own, because there are some interesting hard drives in here that I would like to see if they would still run. I just love these old, Seagate drives here. I think the lowest capacity that I have here is 20 megabytes and goes all the way up to 200. There's also this AT XT compatible drive, so you could use this both on an AT system and an XT system that supports IDE, which is pretty rare. We have a Quantum Pro drive here, 80 megabytes. Quantum drives are known to have these kind of sticky rubber things inside, so that they cause all kinds of issues. Your head gets stuck to the rubber, which kind of starts disintegrating. But yeah, I'll probably do another video where I take a look at all of these hard drives. Here we have another Connor. Connor in particular was used by a lot of these older computers like Olivetti and Compaqs, but I ended up choosing for this Seagate ST3120A, which is a 100 megabyte hard drive. And I was able to use one of the 47 predefined types in the Phoenix BIOS setup utility. Unfortunately, I was only able to format it up to 70 megabytes instead of the full 100 megabytes, but I mean, it's good enough. It's not like we're going to be needing a whole lot of storage on this 286, and I think it's nice to have an old matching hard drive in a system like this. Now, to hook up the hard drive, we need to have one of these IDE controller cards here. So this is a 16-bit ISA controller card. It also allows us to hook up a floppy drive. It has 2 serial ports and a parallel port. Also has a game port. But we can disable certain features here on the card, as some of these ports are also available on our MeTAC motherboard. So we just need to make sure that we disable the COM ports and the parallel port and stuff like that. Now, I wasn't able to get the internal floppy drive controller up and running on this MeTAC motherboard, so I decided to go for this controller card here, set the jumpers correctly, and hook up both the hard drive and the floppy drive on this card. And as I was still running with the original RAM sticks here and I was still debugging certain issues, I just wanted to show you the kind of stuff that you encounter when you are dealing with a bad RAM stick, because the behavior is pretty unpredictable. Initially everything seemed to work fine, but then after a while things started to get messed up. For example, here as I'm selecting a hard disk type, I all of a sudden got this memory parity interrupt error. The machine completely hanged. I couldn't use the S key or the R key to reboot the machine. And as I was rebooting, all of a sudden it only detected 512K of base memory instead of the 640. I got these memory data line failure errors. So it was kind of all over the place. I mean, every reboot basically led to another issue. So completely unpredictable, but most likely memory related. Now, typically you would get these errors straight away as you are booting. For example, here it does it memory count, and then we get the memory parity interrupt error. But on other occasions, it would simply boot without any issues. And as I was, for example, browsing through the hard drive, all of a sudden during a directory listing, I also got this memory parity error. But unfortunately, my 30-pin RAM selection is pretty limited, especially in the SIP department. So I had the original sticks. I also had these other SIP modules here, 1 megabyte each, but these aren't parity chips, so that gave us issues straight away. I had another pair of SIP modules here, but those were only 256K each, giving us a total of 1 megabyte. I pulled these out of an Atari PC 4. And then I had some other random 30-pin SIMM modules, so not SIP modules. And I decided to go with that route, see if I could, use a standard SIMM socket and hook it up to the MeTAC motherboard. But before I did that, I did try to use the other SIP modules, so the one memory sticks here, which don't have parity. Something that I didn't realize at the time was a requirement, but as you could see, as soon as you start the machine, you get these memory parity failure errors. The machine would never boot, so these sticks would be definitely, useless. So yeah, these sticks are definitely not an option. I do have another computer that also has these SIP sockets, so I might try them there. But for these MeTAC/Atari PCs, this will definitely be a no-go. Now, I did pull some sticks from an Atari PC 4, but unfortunately, these are only 256K sticks. So that gives us a total of 1 megabyte of RAM, which, is not all that much for this 286, especially given the fact that this motherboard supports up to 8 megabytes. So it's a bit of a shame to use these. And then that would also mean that my other Atari PC 4 only has 1 megabyte of RAM instead of 2 megabytes. But yeah, with these 4 sticks of RAM, the machine did boot. Obviously, you need to run the setup utility again, and you need to specify these sticks as being 256 kilobit modules, because previously they were set to 1 megabit, giving us a total now of 1 megabyte of memory. But like I said, because I really wanted to have 4 megabytes of RAM in this machine, I again needed to have another option. So yeah, until I find some parity enabled SIP modules, I will need to go with this option, which is a standard component that you can buy off the shelf for hooking up SIMM modules to a motherboard. Now, because SIMM and SIP are pin compatible, for the time being, I'm just going to be hooking them up to these SIP connectors here. I'm not going to be desoldering the SIP connectors because I want to keep this thing original, and I might end up finding SIP modules, but for now I'm just going to see if I can hook up SIMM modules. Now obviously this is a bit of a wobbly fit. So what I did was I attached the SIMM modules beforehand to these modules and then just plug them into the SIP connectors, which is kind of a temporary solution, obviously, but it does allow me to test the machine with SIMM modules. And it took me a while to find a parity enabled pair of SIMM modules also, but once I found those, I did find that the machine was running stable finally. So we get the memory count, 640K of base memory, 3072K of extended memory. We get a total of 4 megabytes of RAM. And we now have a stable setup, which is really nice because now we can focus on the hard drive, getting that recognized and installing some stuff on it. So like I said, the Seagate hard drive here, the ST3120A is the hard drive that we're going to be using. This is a 100 megabyte IDE hard drive, but because I didn't find a matching cylinder head sector setting in the CMOS utility, we will only be able to use around 70 megabyte of disk space on this hard drive. And that's because we're using disk type 45 here, which has 1024 cylinders. It has 8 heads, 17 sectors. And when you compare that to the actual numbers of the Seagate, you can see that we're lacking 4 heads. So if you do the total size calculation, which is cylinder times heads times sectors times bytes per sector, you get the total disk capacity in bytes. And because we have 4 less heads in our setup utility, that makes up for about 30 megabytes of less disk space. And you can see that phenomenon when you load up a tool like fdisk. If you go into the display partition information section, you see that we have a 102 megabyte FAT16 formatted hard drive with a total disk space of 68 megabytes. Now the 68 megabytes is the one that is being reported via the setup utility, and the 102 megabytes is due to the fact that this hard drive was at one time formatted by a machine which did have the appropriate cylinder head sector settings for this hard drive. So, running this hard drive as is with this configuration will result in some errors. So you might be able to read some portions of the disks, but you will not be able to read everything, just because the setup utility in this computer will not be able to recognize the entire disk space. So we need to reformat or repartition that hard drive. But now, as soon as we've repartitioned the hard drive, we can go ahead and install an operating system on it. I decided to go with MS-DOS 6.22 because I had the disks lying around. Now, obviously, for a 286, you can go for a lower version of MS-DOS also. But I just wanted to see if it would survive the installation process, if the machine was kind of stable right now. So MS-DOS was formatting the hard drive. It will then do a quick analysis of your system, and then it will go ahead and copy all of the files from the 3 MS-DOS floppy disks onto the hard drive. Now, I did notice that this took a very long time on the 286. It took a lot longer than I was expecting it to be, probably because this is just a 286 running at 12 megahertz, and MS-DOS 6.22 might be a stretch too far for this type of system. But after about 20 minutes, MS-DOS 6.22 was installed on the hard drive of our MeTAC 286, meaning we could now boot from the hard drive, put some games on the hard drive, and just do some, very basic generic stress testing by just letting the machine run for a while, letting it run some demos of some games, and just making sure that we have the system in a stable state right now. So yeah, here we have MS-DOS 6.22 installed. We still have 65 megabytes of disk space available. So let's do a quick check disk. So it has detected our hard drive as being a 70 megabyte hard drive. We have 4 megabytes of RAM. Let me just load up Microsoft Diagnostics real quick, just to see how it detects the system. So we have the MeTAC Phoenix computer here. It has detected our BIOS version, IBM PC AT, obviously, 286. We have 640 kilobyte of conventional memory, 3072 of extended memory, giving us 4 megabyte of memory in total. The onboard video is also detected as a Paradise VGA chip. We also support digital video outputs so that we can have MDA, CGA, EGA. We have the parallel port. We also have 2 serial ports here. So yeah, everything seemed to be running fine. I did do an Arkanoid stress test by just letting Arkanoid run for a couple of hours, as it will, demo through the various levels of the game, which I thought was a pretty interesting benchmark just to see if it would survive that, and it did. I also installed some other games and spent some time playing them on this machine. I didn't run into any issues, so I have the impression that the machine is finally running stable now, and we can move ahead, focus now on the case and getting all of that rust removed from the case, and just building everything back together again and finally completing this project. So that will be the final part of this video series, where we put everything back together, and hopefully then we will have the final system up and running, stable and ready to go. And so with that, we've reached the end of part 2 of this MeTAC 286 video series. I'm expecting to have just one more video of the system, and then we should be done with it. I really hope you've enjoyed this one. If you did, please consider giving it a like, subscribe to the channel if you haven't already done so, leave a comment in the comment section below, and I hope to see you guys real soon for the next video. Take care, bye bye.